Okay. So today we are starting the new chapter, right, in physics, that is force and laws of motion. Okay. Force and laws of motion. In our daily life, we observe that some efforts need to be required, right, when we put a stationary object into a motion or to stop a moving object, right? So in both the cases, we need to apply the force, the external force, right? So we ordinarily experience that this is a muscular effort and say that we must push, hit, or pull an object to change its state of motion, right? So concept of force is based on this push, pull, and hit. Getting that? So the concept of force is based on this push, pull, and hit, right? So what is force? Any action which causes pull, hit, or push on a body is called force. Getting that? Okay. However, we cannot see the force, but it can be judged only by the effects which it can produce in various bodies around us. Okay. So write down. Okay. So force can produce effects, right? However, we cannot see the force, but it can produce effects which can be seen, right? So what are the different effects can be produced by the force? Is like a force can move a stationary body. A force can move a stationary body. A force can stop a moving body. Okay. Third effect, it can change the direction. It can change the direction and speed of a moving body. Okay. And fourth is it can change the shape and size of the body. Okay. So what are the effects of force? These are some effects of force. Then that whenever a body is stationary, it starts moving if we applied some force on it, right? Similarly, if a body is already moving, then if you want to stop it, then again we have to apply some force. If we want to change the direction and speed of the body, then also we need to apply the force. And to change the shape and size of a body, again we need to apply the force. So these are the effects of forces which can be seen. However, we cannot see the force, right? So any action which causes pull, hit, push of a body is termed as force. Now, forces can be of two types, right? Force can be balanced and it can be unbalanced. Okay. So write down balanced forces. Balanced forces. Now, what do you mean by balanced force? Balanced force means when the net effect produced by the number of the forces acting on a body is zero. Okay, then the forces are said to be balanced forces. Getting that? Please write down. So what are balanced forces? When the net effect produced by the number of the forces acting on a body is zero. Means there are so many forces, different forces which are acting on the body, but the total effect, their net effect is zero. And body state of, this the state of body will not change, right? Then in this case, we say that the forces are balanced forces. Okay, so balanced forces can only bring a change in the shape of the body. Sometimes it can bring the change the shape of the body, right? Now, suppose if a block of wood is placed on a horizontal surface, right? Suppose we have a block of a wood. Suppose this is wood block. Okay, and this is placed on a surface. Sama, switch on the video. Right. So this is a wooden block, suppose. Now, two strings, A and B, suppose, and they are connected to it like this, in this direction, here, and one is here, in this direction. Okay. Suppose this is a string A, and this is a string B. Getting it? And block is in a state of rest, right? Okay. Block is a state of rest, right? Now, if we pull A and B strings with equal magnitude of forces, right? That means if suppose the force which is applied by string A, the person who is pulling this string A is applying the force Fa, right? And here it is suppose Fb. And the magnitude of these forces is equal. Then the block does not move. Yes or no? It will not change its position. Getting that? Yes or no? So if the applied forces, because they are applied in the opposite direction and the magnitude is same, right? Suppose this is 5 Newton and this is also 5 Newton, right? And they are applied in the opposite direction. So what will happen? The state of rest will not change. Yes. So such type of forces are called balanced forces, right? Are you getting that? So here FA is equal to FB, means the magnitude is same, that is 5 Newton, right? So we say that FA and FB are balanced forces. Are you getting that? Why? Because the net force, the resultant force will be 0, right? Okay, so this is the magnitude of the force, right? Remember that force is a vector quantity, right? If we have taken this as 5 Newton, then FB will be equal to FA is equal to minus FB, right? Getting that? Means minus 5 Newton, right? Now, when you add them, then the resultant force will be resultant force or the net force will be FA plus FB, right? And this is 5 Newton and this is minus 5 Newton because it is applied in the opposite directions, right? And therefore the net force will be 0 Newton or it's simply 0. Getting it? So when the forces are having the equal magnitude and they are applied in the opposite directions, right? The net resultant force will be 0. And in this case, the body will not change its position. The rest of this wooden block will not change. And such type of forces are called balanced forces, right? So balanced forces do not change the state of rest and state of motion. If the body is in motion, it will keep on moving. Okay, if the forces are balanced. And if the body is in the state of rest, it will be in the rest state because the balanced forces are applied, right? For example, in tug of war, have you seen the tug of war? Have you ever played that game, tug of war? When both the teams apply similar force from both the sides, right? So what will happen? Rope does not move either side, right? Why? Because the resultant force is 0. And that's why this is a balanced force. Are you getting that? Yes or no? Please tell me. Now, what are unbalanced forces? When the net effect produced by the number of forces acting on the body is non-zero, then we say that the forces are unbalanced forces. Are you getting that? Write down. So since the forces are unbalanced force can cause motion in the body. Okay. Or you can say where unbalanced forces cause a change in the state of the rest or the uniform motion of the body. Okay. So write down. Unbalanced forces cause a change in the state of rest or of uniform motion of a body. Is that clear? Like, again, let's take an example of tug of war. Now, in tug of war, when one of the teams suddenly releases the rope, what happened? Please, when I'm explaining, just listen my words. In tug of war, when one of the teams suddenly releases the rope, what happened? There is an unbalanced force acting on the other team, and due to which it falls in the backward direction. Yes or no? Have you seen that? Right? So if an unbalanced force is applied on a moving object, there will be a change either in its speed or in the direction of motion. Right? So similarly, to accelerate the motion of an object, an unbalanced force is required. Yes or no? Right? So when you are sitting in a car, right? So how we increase the speed? We need to use the accelerator. So what this accelerator is actually doing? It is applying that unbalanced force, right? A force which is required to increase its speed. If the forces are not unbalanced, right? So if the body is in rest, it will keep on rest. It will stay in the rest. And if it is moving, it keep on moving. There is no change in its position, or it is no change in the state of its motion. Are you getting that? Right? So to increase the velocity, to increase the acceleration, to accelerate the body, we need to apply unbalanced forces. Is that clear? Okay. Now you can note down. Now look at the similar example. Again, there is a wooden block on the surface. Okay. There are two strings, string A and string B, right? And now we are applying the force, right? Pulling these strings in the opposite direction. Now this time, FA, force applied towards the string A, right, is 10 Newton, whereas FB is 7 Newton, right? Direction of the forces are opposite to each other, right? Now this time, what will be the resultant force? FA is 10 Newton, right? And FB will be taken as minus 7 Newton. Why we are taking minus sign? Because it is acting in the opposite direction, right? So if you are taking FA, the direction of force A, as positive, then FB will be negative. If you take FB as positive, then in that case, FA will be negative. Okay? So remember this. Now, what will be the resultant force or the net force? Net resultant force will be, again, addition of these two forces, FA plus FB, right? FA is 10 Newton and FB is minus 7 Newton, right? So this will be 3 Newton, right? So what is the net resultant force? It is 3 Newton, right? And because of this unbalanced force, the wooden block will start moving in the direction where FA is applied. Is that clear? Okay. Therefore, block will move in the direction of the force FA, right? Because FA is greater than FB, right? So these forces this time, FA and FB are unbalanced forces, right? So what this unbalanced force causes? It causes change in the state of the body, right? So this block was stationary, right? Since the forces applied are unbalanced, therefore it starts moving. Is that clear? Okay, so therefore unbalanced forces can cause motion in the wooden block. Is that clear? Now, what is Newton's first law of motion? Newton studies the ideas of Galileo regarding the motion of an object. And he formulated three fundamental laws that govern the motion of an object. These three laws are known as Newton's laws of motion. Right? Now, into this, the very first law of motion is that an object will continue to remain in its state of rest or of uniform motion along a straight line unless an external force acts on it. This means that all objects resist change in their state. Okay, so what is the first law of motion? It states that, listen me again, it states that an object will continue to remain in its state of rest or of uniform motion along a straight line path unless an external force acts on it. Right? That means what it says means if a body is at rest, it wants to be in rest. But if it is in motion, it wants to keep, in the same position, in the same motion until an external force is applied on it. Are you getting that? Okay. So write down. In short, what we can say that all objects, all objects resist change. Okay. They resist change in their state. They don't want to change their state. Okay. Right. So it is difficult for you also, right? When you are sitting and you are doing something, right? And your mother says, okay, Anvi, Sama, do this. So what do you say? Okay, mom, I will do this after some time, right? So every object, every body resists the change, right? They oppose the change, right? They do not like, to change whatever, they are actually doing, right? So the state of any object can be changed by applying external forces only, right? It's just an example I told you. Suppose a person standing in a bus, right? And you can see that that person falls backward when the bus is started moving suddenly. Have you seen that? When you are standing in your school bus and going to your school, and you are standing there and it suddenly started, right? So what happened? He falls backward, right? And this happens because the person and bus both are in rest while the person's not moving. However, the bus start moving, right? So the legs of the person start moving along with the bus, but the rest portion of the body has tendency to remain in rest. And because of this, person falls backward if he's not alert, right? Are you getting that? Similarly, a person is standing in a moving bus falls forward if driver applies brake suddenly, right? So person is also moving with the same velocity as the bus is moving. So when the driver applies the brake suddenly, so what happened? We falls forward direction, in the forward direction, right? Okay, so this is Newton's first law of motion. And there is a term which is called inertia, which actually explains this. So put the heading, inertia. Now, what is this inertia? The natural tendency, listen me carefully, the natural tendency of an object to resist a change in their state of rest or of uniform motion along the straight line is called the inertia of the object. Right? So what is this inertia? This is the tendency of the object to resist the change. This tendency of the object is inertia. And it is the inherent property of all the objects. Right? So Newton's first law of motion is also known as the law of inertia. Is that clear? So first write down what is the meaning of inertia. Okay. So inertia is something which is inherent property of all the objects, and every property resists a change in their state. right? So if they want, if they are in rest, they want to be in rest. If they are in motion, they want to keep on moving, right? So this tendency, this natural tendency of every object is called inertia, and that's the reason Newton's first law of motion is also called as law of inertia. Is that clear? Right. So inertia of an object is measured by its mass. Okay. Right. So how do we measure this tendency? It depends on the mass, and it is directly proportional to the mass. Okay. Inertia is directly proportional to mass. That means what? Inertia increases with increase in the mass. If body is having a great mass, if a big mass, then it's having more inertia, right? And you need to apply more force, right, to change its state. Am I getting my point? Right? So if mass is increased, inertia will also increase. If mass is less, inertia will be less. So heavy object will have more inertia than the lighter one. Is that clear? Why? Because inertia is directly proportional to the mass of the body. So inertia of the body is directly proportional to the mass of the body. Is that clear? Inertia of the body is directly proportional to mass of the body. ओके सो जितना बड़ा ऑब्जेक्ट होगा, जितना ज्यादा उसका मास है, उतना ही ज्यादा उसका इनर्शिया है. एंड सिंस इट्स इनर्शिया इज बिग, इट्स लार्ज, you need to apply more force to change its state. Is that clear, Anvi, Sama? Please understand the concept. Writing is not important, right? I will provide these notes to you, okay, at the end of the chapter, and also this is given in your books. Okay, so try to understand the concept in the class rather noting them. Is that clear? Okay, there are certain different types of inertia, and we can divide inertia into three types: inertia of rest, inertia of motion, and inertia of direction. Right? Okay, so there are three types of inertia: inertia of rest. Okay, so what is inertia of rest? The tendency of body to resist or to oppose any change in its state of rest is called inertia of rest. Means अगर कोई rest में है तो वो rest में ही रहना चाहता है, right? Don't want to, change its state. That is inertia of rest. Suppose when a bus suddenly starts moving forward, then the passenger in the bus falls backward, right? Why? Because we want to be in rest, because we were there in that position, right? The carpet is beaten with the stick to remove the dust particles. So what will happen when we beat the carpet? Carpet moves, but the dust particle, they are at rest. They want to be in that position only, and that's why the dust gets separated. Similarly, when a tree is vigorously shaken, some of the leaves falls from the tree, right? So these are all examples of inertia of rest. Then there is another inertia, that is inertia of motion. Inertia of motion means the tendency of a body to resist, to oppose any change in its state of uniform motion. That is inertia of motion. Means if a body is moving, कोई body motion में है, तो वो motion में ही रहना चाहती है. Don't want to stop, right? So that is inertia of motion. So passenger fall forward when a fast moving bus stops suddenly. Similarly, person falls forward while getting down from a moving bus or train. Yes or no? Similarly, luggage is usually tied with a rope on the roof of a bus, right? Okay, so this is because of inertia of motion. And then the third is inertia of direction. Okay, so what is it? The tendency of the body to oppose any change in its direction. वो direction भी change नहीं करना चाहती अपना, right? Right? So tendency of the body to oppose any change in its direction of motion is called inertia of direction. For example, when a fast moving bus, right, and it is taking a sharp curve on the road, then passenger falls away from the center of the curved road. Have you seen that? Your position gets changed, right? Similarly, the sparks produced during the sharpening of the knife against a grinding wheel leaves tangentially to its rim, right? A stone tied to a string, right? And we are whirling in a horizontal circle. right? And if the string breaks, then what will happen? The stone flies away in that particular direction, tangentially. Are you getting that? Right. So these are all examples of inertia of direction. Is that clear?